Hello, everyone. Let me. So let me start off. Let's think. So I'm going to give a little demonstration about LoRa. Zoom. That's okay. Which has been developed by Angus for. He started a couple of months ago. And it's sitting as a pull request in Micropython lib, so you can play with it. And I'm going to show you sort of how it works. But just to go back to Matt's point about Micropython sponsorship, so this work was funded by Micropython sponsorship. And what we're trying to do now is in pull requests and sometimes commits that have been funded or work that has been funded by Micropython sponsorship, we will write that in the commit message so that people can at least get some visibility to see what sort of work is done. And Angus has also been working on USB support to make it a lot more flexible so that you can define your own USB devices and eventually USB host directly in Python. So you can implement, for example, a HID device or a MIDI device or whatever you like. You can implement the full USB device in Python, the endpoints and reading and writing data. So that's the I wanted to demonstrate that as well, but it's not. It's a lot more to show than LoRa, and it's still work in progress. The LoRa work is much closer to being merged. But just to mention, as part of the GitHub sponsorship, that's what it's going towards as well, because we know that people have asked a lot about configurable USB, USB HID, USB MIDI, and other things, especially on RP2040 parts. And now that ESP32 has some native USB, we can do it on there as well, hopefully. And all the other ports that have native USB, which is most of them, will be able to use this USB Python interface. So it's built upon tiny USB. So that means anything that uses tiny USB will be able to use this with in exactly the same way, basically. So that's really exciting, and that will come over the next few months. But you can already play with that. Some people have. But I'm going to demonstrate some LoRa code now. Let me share my screen, share, and go over here. Right, I hope you can see things. So
yeah, we can see that.
Good. So the driver itself is an SX1276 driver that Angus has written, and the driver is 100% Python. Yes, and at least for this SX1276 it is. And so I have. Can you still see my video? If you can.
Yeah, we can do that too.
This is the hardware, one of the hardware that I'm using. So I have a Pi board underneath, and then I've made a little adapter board and then plugged in a. If I unplug it, hang on, I can show you. This is a Modtronics in-air module, which is just a SX1276 inside a can with all the bits that you need to make it work. And it just talks over over an SPI bus with a few other pins. Now I have to remember which way around this goes when I plug it back in. Oh dear. So I do not want to break this.
Rewind the tape.
How do I tell which way it goes? That's okay. I have another one. Obviously, I need two to communicate, but the other one, actually, I can tell. The other one is just wired up with some wires. So ground is going to be there. ground is closest to the antenna. Sorry about that. I did not intend to pull that out. Ground is either there or there. It's most likely there. Okay.
We believe in you, Damien.
I've got to trust myself here. Let me see. At least this is on a current meter, so I can tell if it's. Yeah, no, that's all right. Okay. So I have two of these, obviously, and they're pretty close to each other, about a meter apart. LoRa's supposed to be long range, but I didn't have something set up for really long range. So the demo that I have is just going to send from one to the other, but I'll show you the code that does that, so you can see it's quite straightforward. I mean, all of the details are hidden in that driver that I just showed. So the first thing you need to do is to set define some configuration parameters like the frequency and a few other parameters to set how you're going to transmit and receive, and then create the LoRa modem class, which you can use to send and receive data. So it'll be on a SPI bus, and you need a chip select pin. You can also have a reset and an IRQ pin. I don't have those wired up, but this is the simplest case where you just have a SPI bus, and then we create our modem driver here by instantiating that class, the SX1276 with the SPI bus chip select, and then also pass in the configuration. So this modem object now is ready to send and receive. And then I have a few demos here, which I'll run for sending and receiving. There's synchronous and then async. So it supports async IO and also non-async IO, just synchronous. So there's the receiving and the transmitting tests for async and sync. And down the bottom is just for the async versions, you have to run async IO. Just does that. So let's try and, first of all, okay, so on board number 1 here, I'm using MP remote. I've just got shorthand as MP. So I'm going to run the demo py, which is the script there, and then I'm going to execute, say, the RX sync function. Okay, that sometimes happens the first time. Angus, you might be able to tell me why. But so now it's running the synchronous receiver. It's got a timeout of 4 seconds here, 4,000 milliseconds. So it's waiting for a packet, and if it doesn't receive one in 4 seconds, it just prints none because it didn't receive anything. Now, so the bottom right here, I will run the same code, but on a different board. So A1 is TTY ACM A1, and I'm going to run the TX synchronous code. So the TX synchronous code is here, which will 4 times send a message with an index, so message 0, 1, 2, 3, and then it will wait 3 seconds. So with LoRa, you're not supposed to, I guess, transmit too often and too much data. So I'm just going to transmit 4 times every 3 seconds. So if I run that, you can see in the top, it receives just as it sends. So it takes maybe 500 milliseconds to actually send. And then you can see above it receives it almost immediately after it was sent. Well, it should. So the data is this first element of the tuple. I'll just stop that so it doesn't scroll. This, I think, is a signal to noise ratio, and this is the RSSI, which is very low, but you kind of expect that for LoRa. Although when they're only a meter apart, I expect that to be higher. So there might be something wrong with maybe the antenna setting, but regardless, we can still receive without a problem all the messages that were sent. So that's really it. You can send and receive data. And on top of that, you can build, obviously, whatever you like once you can send and receive. This is not yeah, so this is not LoRaWAN or any other higher protocol. This is just simply sending a LoRa packet and receiving a LoRa packet. If I do the asynchronous test, so just so you can see it runs in async IO. So the synchronous test was on the receiver was just really calling modem receive and in a loop. The asynchronous test is just going to do asynchronous modem receive with an await. So that's obviously very useful if you're in an async IO program, because this can be a task that can just sit there waiting for packets. So if I run that, and then I can do the async IO version of transmit. Obviously, you don't have to do both async IO. One can be synchronous and one can be asynchronous, because either side doesn't matter how they're implemented. But I'll show the asynchronous transmitting, which is, so the synchronous transmitter is obviously quite simple. It's just doing a loop that we saw before and transmitting. And the asynchronous version is exactly the same, except we've got await transmit and await sleep instead of synchronous transmit and synchronous sleep. And so, as with the transmitter, this can run as a task in a bigger application and not block it. So if we do transmit async, we should get exactly the same thing as before. So, except it says async message instead of sync message. Oh, that one got missed. There we go, and that last one got corrupted. So yeah, it's obviously not going to be perfect. We can try again. I think that corruption is actually something to do with the SPI, because there is a CRC checking, and so ignore this, Angus. We might want to talk about that later, but I'm pretty sure you shouldn't have corrupted packets. So we only got 2 packets again. Let's try again. 0. No, even the 1 didn't come through. I can move these things closer together, but I don't know if that will make a difference. There, 0 and 3. Anyway, you can see it works. So on top of this, eventually we can implement LoRaWAN, talking to the Things network and other networks around. That's not going in the pipeline at the moment. The idea is that the code that you see here is, or the demo code, is not part of the driver, but the driver itself, we're pretty happy with. Thought it works, and we just want sort of people to see what people do with it, and if there's any feedback on how to improve, we can add more features. But I think this is a good start for if you need to send and receive LoRa packets, which is like the fundamental thing. Also to note that we do support the STM32WL, which is STM's LoRa sort of combined chip that has a Semtech SX, I think 12 something in it. 1262, I think it was. Internally, as sort of side by side in the silicon, with next to an STM part. So that also we will support. That requires a bit of C code to get working.
It's also using these boards too, Damien. They're where are they from? Yeah.
Okay. Is it a seed board? Or?
Yeah, it's one of the seed E5 boards, I think they call it.
Okay.
There's a couple of different boards they sell them in, but if you can see, they've made a module based around the STM32WL chip, and that module it's literally just an STM32WL with a particular pin out. It's a bit annoying because they haven't broken out boot 0, but otherwise it's identical to their. The guts of it is the STM chip.
Okay. Yeah. So with this driver, we should be able to support most things out there, because the Semtech is quite similar in all its different forms. So yeah, I mean, there are a few different versions, and obviously you can see here they are a bit different. But I hope that most of the use cases can be covered by what we have. So yeah, if you want to have a look, it's on Micropython lib. Let me see if I can find a link. Pull requests. So there's also this other driver, but this is the code I'm using here. 501 Micropython lib. So if you're looking to play with LoRa, I think this is a good starting point. And yeah, this will hopefully be merged soon, and then it'll be up for issues and improvements. There's also, that's that. Are there any questions to do with anything I've said so far? Is there?
That's awesome. I just soldered my LoRa board, ready to go, so I'll test it in a bit. That's really cool.
Yeah, I do plan to make some sensors for our garden and just leave them running on a battery and see how long they last. I guess you can't get a REPL or anything because LoRa's not for that, but if it can just send sort of temperature and some other environmental sensors, that will be quite cool.
So you mentioned that you shouldn't broadcast lots of information. What is that, just out of courtesy for others using the airwaves? Okay.
Yes, I mean it's unlicensed. It's the unlicensed spectrum, so you're free to transmit within the bounds of transmission power that are set. But I think for the actual LoRa usage, there are guidelines on what rate and how much data you should send. But
don't ruin it for everyone.
But yeah, I don't know what those numbers are. I need to learn.
Yeah, I can't remember the numbers too, but once you're on a LoRa WAN network, that they're also you get throttled if you try to send too much. So
find trouble.
But yeah, it's pretty amazing technology that it can go so far. The power that I was measuring, I think it uses about 10 or 12 milliamps to sit there in a receiving loop. Well, not a loop, but just sit there listening. I think I get my numbers here. It was about 12 milliamps receiving, and it's about 13 milliamps receiving and 30 to 45 milliamps when transmitting a message, which I thought was a bit high, but apparently that's what it takes. So you don't want to be transmitting so often if you're on a battery, and also not listening for the whole time. Anyway, that's this is all obviously work in progress, so please take a look if you're interested. The other thing I will say before I finish, so the next release 120 is obviously not out. It's just taken a long time, and there's Jim and I have been trying to get through the backlog of pull requests, which we got through about 35 or so last week. There's just lots of things going on. There's been lots of really good contributions, and I think I've been doing very little of my own work, but just reviewing code for the past few weeks. Sometimes it takes a lot to review just one line, and then other times 1,000 lines can be easy. But it's good. It's good to see such good contributions. But yeah, the next release is on the top of my mind to do, and we'll try and get it out as soon as possible. And then from there might be another release of this Micropython version 1 series, but we do want to move to Micropython 2.0 sooner rather than later, which we will. The aim for Micropython 2 will be to make some backwards incompatible changes that are sort of have been long coming and that will hopefully improve things for, well, moving forward. But we can't make these changes just in sort of a one series release, because they will break too much code. So for example, things like improving date time so that date time tuples are the same everywhere, for example. That needs to be done, but it's going to break a lot of code. Making the epoch as 1970, again, should be done, needs to be done, but it will break code. And then another thing we want to do is to perhaps change the way boot sequence works, so that we can optimize things, make more things into Python, make things more configurable. So there are a few things that are really breaking changes, and I think MicroPython 2.0 would be a good place to introduce those. So when we have an idea of all the things that want to change, we'll make a sort of discussion on GitHub so people can see and then give feedback. But yeah, just to give you sort of a view into what the plans are over the next few releases. That's what it is. All right, I've stopped sharing.